as you can see here, we have a number of points which define a number of lines, and ergo a number of segments and a number of angles. First, what we know, angle GFH is equal to 131 degrees. What is angle GFH? Well, that is angle GFH. It's this entire angle here. All right, the angle spanning GFH. So this entire angle here is 131 degrees. Next, we know that JFH is 42 degrees. Angle JFH, this angle right here, is equal to 42 degrees. So this part here is 42 degrees. Okay, we want to discover, our goal is to find out what angle JFG is, or another way of saying it, what is angle GFJ? It's the same thing, and I'll write that here just so you can see. Angle GFJ is equal to angle JFG. It's more than just congruent because it's the same angle. Okay? So, how are we going to figure this out? Well, we know that the whole thing is 131. Okay? Wouldn't that whole thing be equal to the sum of this angle here plus this angle here? Or, if you like, it's equal to 42 degrees plus our unknown, or plus angle GFJ. Put a little degree sign up there. This is an easy enough problem to solve. Basic equations, we just subtract 42 degrees from both sides. 42 cancels out. We're left with 89 degrees. It is equal to angle GFJ. And that is our answer. And that makes sense, actually, because if you look at this angle up here, and then not all diagrams are drawn to scale, but in this particular problem, if you look at GFJ, it almost looks like a 90-degree angle, doesn't it? Right? It almost looks like a right angle. Well, it's 89 degrees, which is extremely close, so it does appear that this is drawn somewhat to scale. All right, we'll do one more of these, and then we'll continue on our way. Thank you. All right, here's our next problem. The only difference between this problem and the last one really is that I've used some different types of notation here, and that's just to get you used to the different ways to write things. In mathematics, one of our problems in my mind is that we actually aren't very consistent with the way that we write things, and so there's a lot of different notation out there for a lot of different geometries, calculus, etc., etc. People fight over who discovered what and how to write it. But for now, we have some different notations here, and I want to just review them quickly. Here you'll see M angle 1. Well, all this means is that angle 1 is equal to 33 degrees. This isn't a less than symbol, okay? And that's why whenever I draw my angle, I always actually draw a little line through it like that. And in fact, I'm going to go ahead and just write that like that. So whenever I write angle, I always make sure to write it as such. Okay? Now, here they're calling angle GFH, or angle 1. They're calling angle GFH angle 1. That's not a problem, right? It's the same thing. They just decided to label this angle 1. So angle GFH is angle 1. Next, angle GFJ is 62 degrees. Angle GFJ is 62 degrees. This entire angle spanning from here to here, that is 62 degrees. Okay? So, and let me write in here, this angle right here between angle 1, that's 33 degrees. Our objective is to find out what is angle 2, otherwise known as angle HFJ. Okay? So, how are we going to find this out? Well, the whole thing is 62 degrees. So wouldn't 62 degrees be equal to the sum 33 degrees plus the unknown angle HFJ? Okay, how are we going to solve this? Well, let's just subtract 33 degrees from both sides of the equation. That cancels out. We're left with angle HFJ is equal to 29 degrees. 62 minus 33 is 29. And there you have it. The answer for what angle 2 here is equal to 29 degrees. All right. Thank you very much. Have a great day. Goodbye.